Okay, so before we start actually finding the zeros of polynomials, I want to give you a brief introduction of vocabulary. Whenever you're asked to find the roots, find the zeros, find the x-intercepts, find the solutions, find the answers, these all mean the same thing. What you're really looking for is, well, you could be looking for everything, all the zeros. So we'll start with the real zeros. The real zeros are the ones you can see on a graph. It's your x-intercepts. It's where it crosses the x-axis, where the graph is crossing the x-axis. Those are your roots, your zeros, your x-intercepts, or your solutions, your answers that you're looking for. Now, these are real because you can see them. Now, depending on the polynomial, you can have a few real and a few imaginary solutions, but imaginary solutions always come in twos, so you always get it in the form of a plus bi or a minus bi. Notice that the sign changes only in the middle with the imaginary part. So if you have like a parabola, then you're going to get two imaginary solutions if it's not crossing the x-axis. So it could be going up like this, or it could be upside down and never crossing the x-axis. So we're going to continue with this. Now, with the linear equation, you only have one solution. Those are the only ones. We're good at solving linear equations. You only have one real solution. It will always cross the x-axis if you have a line that's going uphill or downhill. Okay, we're not going to talk about vertical lines or horizontal lines. Just if you have a line that's going uphill or downhill, it's going to cross the x-axis at some point. So that's one real solution because you can actually see it. It could be a positive number, it could be a negative number, it could be a fraction, it could be a decimal, but it will always cross the x-axis. A quadratic equation, you know, when you have ax squared plus bx plus c equals 0, that's a quadratic equation. It has three possible types of solutions. You can have one real solution, crosses the x-axis one time, if it only touches it there. It could have two real solutions, where it crosses the x-axis twice. Then you get two real solutions, two roots or two zeros, whatever you want to call them. Or you can have the possibility of two imaginary solutions. Now, you will always get two solutions. Now, well, right here you said it's a one solution, but this is a double root. That means it crosses it twice right there. If it was 2, for example, if that's 1 and then that's 2. And so you can either have two imaginary solutions, two real solutions, or one solution for a quadratic. As you get bigger with the cubic function can have the following types of solutions. Now, the solutions must add up to the degree. So if you have a cubic, which is a third degree, then you should have three solutions. So you can have either three real solutions. That means you can see them on the graph that they're crossing the x-axis. You can have one real solution with two imaginary. So these are the two different ways that you can see the solutions for a third degree. Either you can see them all three, or you can see one of them, but then you have two imaginary. Notice that these add up to 3. Okay, a quartic function can have the following types of solutions. So if you have a quartic, it's kind of like it's kind of like x squared, but a quartic is ax to the 4th, okay, plus some stuff over here. So you can either have 4 imaginary solutions. That means that the graph is never going to cross the x-axis, or it could be upside down, kind of like this. And so this is never going to cross the x-axis, so you would get 4 imaginary solutions. Or you can have 4 real solutions where you see the graph crossing the x-intercept. So remember, these are called x-intercept solutions, zeros or roots as well. Or you can have two real, where you see two of them, and then two imaginary. Notice they add up to 4 solutions. A quintic would be like x to the 5th power. You can have all 5 real solutions where it crosses at 5 different points on the x-axis. You can have 3 real, where you see 3 times that it crosses the x-axis, and then 2 imaginary. Or you can have 1 real and 4 imaginary. Notice that if you add 3 plus 2, that's 5. Or 1 plus 4, that's 5. Because it's a quintic. A quintic is ax to the 5th power, plus stuff over here. Okay, so this is just so that this is just a brief introduction, okay?